Okay, so this demonstration is just going to be verifying the symmetry of the output waveform on the AFG31052. I'm just going to do the one channel again, so we'll swipe across and we'll put him up, and all the tests are going to be done at 800 kilohertz. The reason for that is this is the maximum frequency that the ramp function can handle, and you see it's switched to 800 kilohertz automatically when you change to the ramp function. So to do the measurements, I'm going to do this on the Picoscope, because Picoscope software has a really good little tool in the math channels that I have actually already set up, and with this here I can delay the waveform across the time axis, which is what this bracketed, square bracketed function is doing here. And the 625 microseconds that I've got there is based on the 800 kilohertz frequency. It's actually half of the period time. I can get the period time very quickly by doing that. You see it's 1.2500 microseconds. So in actual fact it's 625 nanoseconds I've set that up to. I apply that to the channel that has been inverted, and then this part of the function here, this last part, subtracts all of this from the original A channel. So I'll be taking the waveform, I'll be shifting it half of its period, inverting it, and then subtracting it, and that will give me the symmetry. Cancel him off because I don't need to, and just enable him. Okay, and then we'll switch the output on, and we'll wait for him to set himself up. And we need a trigger. Just do is take the channel, take it down to around about 35%. So he's at the bottom here now, and you can see he's a straight line, and that's showing that the symmetry on this waveform is fine. You can go another, right, probably there you go. Probably flip it the other way. There you go. We'll leave it like that. So that's the triangular waveform. Any lack of symmetry would have been shown as spikes in the grey line across the bottom here. But triangular is fine. We'll go to sine wave, and you can see that's also fine. You get square wave, and you can see that's generally fine. You can see a little bit down around here. Very, very minor detail. And you can visually see that in the waveform as well a little bit if you look at the top and bottom. And then the final one to go to will be pulse, which is pretty much the same. The only thing that I can do with the pulse is to slide him down. If I change the duty, you will be able to see the waveform will start to respond. You can see the lack of the symmetry displayed around here in this bottom waveform when I change the duty from 50% to 60% and back again. So that's the symmetry of the waveforms displayed. Hopefully it's been useful to some people. Thanks for watching, and I'll see you again in the next video.